This is going to be theorem 2.050. It says that the length of the upper base is not equal to the length of the lower base in a Saccheri Quadrilateral. That should be a little bit further. So for the proof of this, we'll start out with a Saccheri Quadrilateral. So given a Saccheri Quadrilateral ABCD. I'm not going to be spelling out everything as I go along. I think if you've made it this far, or if you're in a hyperbolic geometry, you can, whenever I just name an angle inside this box here, if you do need to spell it out, you'll know how to do that. So A, B, C, D. We'll actually spell the lower base, say with lower base AD. So that tells us exactly what the Saccheri Quadrilateral has to be. Because it's a Saccheri Quadrilateral, we know that these are I don't want to do that in yellow. We know that these are congruent. And we know that these are right angles. First we'll say, suppose BC is congruent to AD. Let's do that. We'll do that little part in purple. So BC is congruent to AD. Construct AC. So we now have this line AC going across here. And we'll pretend that that was drawn better than it was. Then by side, 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 triangle ABC is congruent to triangle CDA. Then by corresponding parts, of congruent triangles, angle B and angle C are right angles. Let's see. Let's draw some measurements in here. We know this right here will be equal to this. And we also have this section equal to this section, or congruent or equal angle measures. Let's see. We also have the congruent angles as drawn. Then the angle sum of triangle ACD equals measure of angle. Let's label these. We'll label them in orange. We'll call it 1, 2, 3, and 4. So that is equal to the measure of angle 1 plus the measure of angle 4 plus the measure of angle D. Then measure of angle 1 equals 90 minus measure of angle 2, which is equal to 90 minus measure of angle 4. So angle sum is equal to 90 minus measure of angle 4. Well, angle sum of triangle ACD equals 90 minus the measure of angle 4 plus measure of angle 4 plus D, which is 90, which equals 180 degrees. This is a contradiction because we do not have triangles with this angle measure in hyperbolic geometry. Therefore, BC is not congruent to AD, is not congruent. I'm not sure if that's an accepted symbol up there, so that's something I've always used. Or not always, just occasionally whenever needed. Or another way to say that is BC is not AD.